Okay, this is 4.6, graphs of other trig functions. We've been graphing sine and cosine, and this lesson is going to talk about the graphs of the other 4 trig functions, starting with tangent. So we're going to start with the function tangent x. Remember, the quotient rule says that the tangent is the sine. I'm going to move this up just a little. The sine of x is just an angle, over the cosine of x. Okay? And because that is division, we know that the cosine of x cannot equal 0. So in other words, it will be undefined where cosine of x is equal to 0. It will be undefined there. Okay? So if I look at where it's undefined, that's going to be where my asymptotes are located. All right? So if I draw this out, this is going to be pi over 2, and this over here will be negative pi over 2. And if I think about what is the tangent of pi over 2, well, the tangent is the sine of pi over 2 over the cosine of pi over 2, which is going to be 1 over 0, which is undefined. So at pi over 2, there's going to be an asymptote. At negative pi over 2, that's just the same thing as 3 pi over 2. And so, of course, the sine of 3 pi over 2 is negative 1, and the cosine of 3 pi over 2 is 0, once again undefined. So we have our asymptotes. The tangent of 0 is going to be 0 over 1, so that will just be 0. All right. We know that the tangent of pi over 4, which of course is halfway, right? So this would be pi over 4 and negative pi over 4 is going to be equal to 1. So I'm going to go up 1, down 1, and this will be 1. The tangent of 7 pi over 4 is going to be negative, so that'll be negative 1. And so that's here. So the tangent function looks like this. Kind of like a cubic function. Now, this is just one period. This is one period of a tangent function. So it is also, it's not sinusoidal, but it's cyclical. So in other words, if I extend this out to 3 pi over 2, there'll be another asymptote there. Here, halfway between is at pi, right? That'll be 0. And it's going to look like this. So it's going to be a whole bunch of these. And the period is going to be from negative pi over 2 to pi over 2, which is pi. Okay? So the period, it's a periodic function is what it's called. Periodic function, which means it repeats, continues to repeat, but it's not continuous. So you can see here that it comes from negative infinity to 0 and then to positive infinity, and the range, same here. And then the domain is going to be all reals except for the angles that are pi over 2. So negative pi over 2, 3 pi over 2, 5 pi over 2. Okay? So that would be that. So on here is the general formula for the tangent. A still controls the amplitude, and B is also going to be used like we did when we were doing sine and cosine, only the period is not 2 pi, it is pi. So the period will be pi over B, and the amplitude will be A. So y equals 2 tangent x. The amplitude doesn't have a whole lot of effect on the tangent graph. It might make it a little shallower here, like a little shallower, like more like this and then up, or sometimes it will make it stretch, so it'll be just a little bit longer, but it's still going to have this basic form. Now this will change, but the other won't. So this is what a basic tangent graph looks like. So here's an example. The amplitude for the tangent graph, this would be, the amplitude would be 2. The period, we know that b is 3, so pi over 3 would be the period. Okay, so that means that if I divide pi over 3 by 2, it's going to be pi over 6 on one side and negative pi over 6, because the period is still going to be pi over 3. So I've got half on either side. Okay, so my asymptotes are going to be there on either side. Okay, and it has an amplitude of 2, so I'm going to draw it like this, and I'm good. Okay, so pi over 3, that's your 2 tangent 3x. So finding your period. Okay, so here are two functions here, tangent 2x and negative tangent 2x. I'm going to graph them both on the same graph. So the first one I'm going to do is the tangent 2x, which the amplitude is just going to be 1, and then the period is going to be pi over 2. So half of pi over 2 is going to be pi over 4, and negative pi over 4. And that's where my asymptotes are going to be. Okay, and then I'm going to go ahead and just draw that in. Boom. Okay, now, the only difference between tangent of 2x and negative tangent 2x is the... okay, from this other one over here, we have a negative out in front. So it's a reflection over the x-axis. And this is the x, right? So what this is going to mean is that instead of going from the bottom like that, this is what it looks like. So negative 2 tangent x has the same period, but it's a reflection over the x-axis. Okay, cotangent x, if you recall, is cotangent is the same thing as 1 over tangent x, which that did not come out the way I wanted it to. 1 over tangent x. So in other words, cosine over sine, upside down, right? So the asymptotes are going to be where sine is equal to 0. The asymptotes will be where sine is equal to 0. Well, sine is equal to 0 at 0 radians, 2 pi, and also pi. So that's where your asymptotes are going to be. So the cotangent graph looks an awful lot like the tangent graph, except this is pi, halfway is pi over 2, half again, and this is, okay. So the cotangent then of pi over 2 is going to be 0, and cotangent is going to go this way. And also this way and this way. Okay, so this is the cotangent graph, and it looks very similar. See the pattern between it. The cotangent looks like the tangent, the negative tangent, moved right. That's pretty much what it looks like. And the period on this is still pi. It's just moved over. The asymptotes are different. So in other words, at the cotangent of 0, it is undefined. Asymptote there. And the cotangent of pi is also undefined. That's where the asymptote is. So it's going to repeat the pattern, and there'll be an asymptote every pi, going to the positive infinity and to the negative infinity. The secant graph, if you'll recall, secant is 1 over cosine. So that's how you start it. You draw a cosine graph. Cosine, so 1, -1. And draw that in. I always do the 5 points. Here. There. And then come back down over here. Okay. So for the secant graph, what you're going to find is that the asymptotes are where cosine is equal to 0. And so you can see that that would be here. Cosine is equal to 0 here. The cosine is equal to 0 here, an asymptote. Cosine is equal here. There'll be another one over here. All right, and then the secant graph is just going to be, jump down, it'll be the part in red only. The part in red only. So you use the cosine graph to draw in, this matches, this goes here. Okay, so is this, so is this. Okay, so the red is the secant graph. But you use the cosine graph to do it. I don't know, it's kind of cool. Okay, here's an example. So we're going to use the cosine graph. So I still need the amplitude and the period. The amplitude is going to be 2. The period is going to be, I know what b is pi, so the period is going to be 2 pi over pi, which is 2. So I'm going to go ahead and divide this up like I have on every other cosine graph that I've done. Okay, only this time the amplitude is going to be 2 and -2. So secant, you remember, is cosine, so I'm going to start here with my cosine graph. And this time when I put this cosine graph in, I'm not going to make it a solid line. I'm just going to make it a dotted line. I'm going to continue this over here. I could continue this one over here as well. But I know that the asymptotes are going to be where the graph of cosine is 0, because you can't divide by 0, right? And so your final graph, the actual secant graph, is going to look like this. All right, so now we're to cosecant. Cosecant is equal to 1 over sine. So guess what we're going to use? We're going to start with sine. The amplitude is 1, the period is 2 pi, so I'll start with 2 pi and pi over 2. 1, -1, right? Graph sine. I'm going to use dotted lines to graph sine. I should have on that first graph. Okay, there's sine. And this will just keep going, right? So now where are my asymptotes? It also has asymptotes because sine cannot, it's going to be where sine is equal to 0. So let me draw those in. Here's an asymptote here. Sine is 0 here, and sine is 0 here. And then the actual cosecant graph will be between the asymptotes. Come down, it will touch the sine graph and go back up. So the actual cosecant graph is in black. All right? And it does not cross the asymptotes or touch them. It gets up close to them and doesn't. So this whole thing is one period of the cosecant graph, period, and that is 2 pi. Okay, and just like when we did the secant graph, these cosecant graphs and tangent graphs are just like those. The amplitude just makes them further away from the x-axis. The period makes it shrink horizontally or stretch. And that's it. So be sure you get these notes in your composition notebook and be ready to do some major graphing when you come to class.